up so that we can have this for later. Guys, remember, you need 4 terms. Do you see it? Yep. You need 4 terms to be able to factor. The ax squared stays the same. What happens to that middle term? Miracle? What's going to happen here?
You write the negative 3 and 2 or negative 2, 1, and 3.
So just this?
With the x's on them.
Okay, so we need to make sure we keep, those are just the coefficients for x, that's still negative 18x. Now I can start to factor, right? And so Jamarcus, this is where you tried to start with that grouping right away, but if you don't have 4 terms, you can't have 2 groups. You have to have that 4 terms, okay? Looking at the first 2, what do they have in common?
3.
And so I'd be left with x minus 7. 3x minus 21 have what in common? And I would be left with?
X minus 7.
Both have an x minus 7. Both have and then we'd be left with 3x plus 3. Notice you may have actually gotten 3x minus 21 times x plus 1. And that's because that factor of 3 was over here. Both of those would be equivalent, but I can factor that common factor of 3 just out in front, and I'd be left with x minus 7 times x plus 1. That's the true factored form of this quadratic, or the simplest. Would I accept these 2? Yes. They're just harder than doing this one. If I had just done this one, a times c is negative 7. What factors in negative 7 add up to negative 6? Negative 7 plus 1, right? Those are the only factors of 7, right? 1 and 7, so that would be it. Notice that makes our job way easier. Anytime you can deal with smaller factors, your job becomes easier. And so, x squared minus 7x plus 1x minus 7. X squared minus 7x have what in common?
X.
And I'm left with x minus 7. 1x minus 7 have what in common?
1.
Technically nothing, or just 1, right? So I'm going to factor out a 1, and I'm left with x minus 7. I do want to point out, when I have those parentheses on the inside, I use those brackets. Could you use parentheses? Yes. They just get mixed up a little bit, right? So typically when you have parentheses outside of that, you would put brackets to keep those separated. But it can still work. When I look inside of here, what do they have in common? So I factor out my x minus 7, and I'm left with x plus 1. So, does it work either way? Yes, Mr. Kinney? 100%. Guys, we gotta wake up. Yes, it works. Now, we just need to be aware that we need to make sure that we're making our life easier. We gotta make sure that we also pay attention. Yes, can you get a vertex form for this one? Yes. But if I ask you to factor, make sure you're paying attention to that, okay? We gotta keep those 2 different strategies separated and remember which one is which. And we'll do a lot of vertex forms today. Questions, comments, concerns before we continue? Okay, and remember, these are just 2 different strategies to approach this one. The main idea is A times C method of factoring. But you could have factored out the greatest common factor first. So there are no questions. We are going to continue with today. Did someone ask a question? I can't hear you. What did you say? Okay. So, quick couple of reminders. Why are we here? It's not to punish us. It's not to keep our parents out of jail. Why are we here? To learn. Learning is good, guys. I hope that you understand or start to learn that. Like, I know that I can't force you to believe that, but it is a beautiful thing to learn and to grow. It's a beautiful thing to get better at stuff. Is it difficult at times? Yes. Right? But just the other day, Jamarcus, you were bragging about how much you benched. 245, is that what it was?
275.
275, geez. So, did you just magically get there? No, it feels good to bench 275, right? But at the same time, you had to work hard to get up to that point. It feels good when you master things. It's beautiful when we learn how to think. It's beautiful when we learn how to learn. It's beautiful when we learn how to analyze situations, make arguments. But there is work involved in that, and that's okay. Let's actually appreciate the work. Let's learn to work hard so that we can grow and learn to appreciate our intelligence. Because your intelligence is not something that is fixed. It is something that can grow over time with effort. And one of the big things I want us to remember with all of this, and I haven't mentioned this before, or I haven't mentioned this recently, but what is math? It's the study of patterns and relationships. We want to notice patterns and relationships that are all around us, right? There's that pattern that when we can find factors of A times C that add up to B, I can factor and I can do stuff with that factoring. It reveals the roots, it reveals the zeros of quadratics. When I can't factor, what's a thing that I might be able to do? That we started really talking about yesterday. We can do the vertex form, right? That's a pattern. And we need to learn how to analyze situations and identify those patterns. I'm going to quickly look at the homework question with y'all. Focus on completing the square, and I'm going to teach you one last strategy about what to do when you can't factor or even use the vertex form. And I will go ahead and tell you this. It involves memorizing an equation. Go ahead and prepare yourself to memorize the equation because you have to know the quadratic formula. It is a method that will always work. I don't know that it's the simplest, but it is a method that will always work. Okay? So, yesterday I asked you to do C right here, right? There are no factors of 12, that was A times C, that add up to negative 10. So what did I do? I converted it to vertex form. How did I get that x minus 5 squared minus 13? Hayden, you live? You with us? Okay. Do we need to talk about that problem? Write some notes to make sure that we can try this on our own later. Extra steps, because we actually attempted it, right, Sanaya? No? Didn't attempt it? Okay. Should I go through this as a precursor to help us get ready for today? Guys, I need you to attempt your homework. Like, I haven't collected any of these 5 because I wanted it to be more of a learning opportunity, but I will start collecting homework every single time, and not in a good way. If you get it wrong, then you will get 0. Start attempting your homework so I don't have to get to that point. Okay? So, just attempt it. It was one problem. That was it. So, I could not factor, so I wanted to get what form? Vertex form. So what's that first thing we should do, Preston, if I want the vertex form? Oh, very close. That'd be the second thing I want to do. You're not wrong. Like, I definitely want to do that. But even before I do negative b divided by 2a, why are you doing negative b divided by 2a? You want what form? Vertex form. So what should you write first? Guys, take the time to write out your formulas. Guess what? I said it 1,000 times. I'll make it 1,001. That may be a slight over-exaggeration. Every time you write the formula, the better you are at remembering it. There is a literal connection between your hand motion and your brain. When you write out the formula, it will help you remember the formula. It's got to be rote memory at this point. We've got to know that vertex form. Because, right, you said negative b divided by 2a. That's definitely something I want to do. But what is negative b divided by 2a in that formula? So we know negative b divided by 2a, but we've got to know what that stands for, right? Jayla, do you remember what that's calculating?
H.
That's our h. That's the whole point, is that is the h. That is the x value of my vertex. I got to know that. So David, negative b, what does that come out to be? You alive? You awake? You with us? Huh? Okay, very close. David said negative 10. Why did I only say that's close for negative b? No, I'm only asking what is negative b right now? Why is it just 10? Remember guys, that is literally saying the opposite of b, right? Right now, what is b? Negative 10. The opposite of the negative 10 would be positive 10. You've got to be careful about that, otherwise it will mess you up. 2 times, what is a? 1, right? Cam, I don't see a number written here. Why is a 1? You alive? You with us? You focused? So why is Ethan saying a is 1? How are you going to identify it then? Because we need to know what a is, right? Tevin, can you help Cam out? Huh? Why is Ethan telling us that a is 1? What do you mean the a? Like, what are you seeing? I need a little bit more of that. You're getting there. Come on, who can add more details onto that? Marshall. I know, but it's not in front of the x. It's in front of the x squared, and it's an understood 1 because how many x squareds do I have? I have 1 x squared, right? It's an understood 1x squared. If it was anything different, I would have to have that coefficient there. It's an understood 1x squared. And so h is 5. I've already said this a right here is 1. Jalen, what's the last thing I need from this equation? Or for this expression?
Okay.
I need the k still, right? Naisha, how am I going to figure out what k is? Do not forget, k is just the, starts with an O, output for the input of h. So I'm going to substitute h in to get k out. So k is equal to 5 squared minus 10 times 5 plus 12. Guys, you got calculators, type it in. What is 5 squared minus 10 times 5 plus 12? You need to take a lap around the room. Stay awake.
13.
What is it?
13.
Very close.
Oh, negative 13.
Negative 13. And so when I substitute everything into this equation, or into this expression, I get 1 times and we've got to have the minus h, right? X minus 5 squared.
Minus 13.
Right, you can do plus negative 13. Typically we would write that more easily as minus 13. Now remember though, this is equal to 0. That's which form again right here? Standard form. Can you ever solve a quadratic in standard form?
No.
No. So we couldn't factor it, so we took that standard form and we rewrote it in vertex form. Remember, these are the same exact functions. Right? Or the same, yeah, same exact expressions. They're equivalent, they just look different. So it is equal to 0. Let me ask you all an important question, because I can do this in just a couple seconds. Do I need to show how they are equivalent, or are we okay with accepting that they are equivalent? Show it? Okay. Does anybody have an idea of a strategy we could use to show that that vertex form and the standard form are in fact the same function? Or same expression? We can graph it. Remember, that's one way to quickly check ourselves, and you will have your calculators available to you. Okay? Take the second to graph them both. That's not what I want. I want a graph page. And I'm going to type in, I think it was x squared minus 10x plus 12. And then x minus 5 squared, whoops, an extra, minus 13. And there's technically the 1 here. Notice, they are different forms of the same exact expression. We know that because those two curves are what? Those two parabolas are, starts with an M. We know they're equivalent because they are matching. The term we use in mathematics is mapped. They map right on top of each other. Does that make, do you see that now though? Like that's what I want you to understand. We're not creating a new equation, we're just rewriting in vertex form. And why are we rewriting it in vertex form? What is the goal? Why is this vertex form so useful?
We can factor it.
Say again.
We can factor it.
Okay, so we couldn't factor it, so why do I want it in vertex form? What can I do from this vertex form? Who stole my eraser?
It wasn't this one.
What can I do when I see vertex form? Remember, if I have factored form, what key idea am I trying to use to solve? Zero product property, right? I want a product of zero, but when I have a vertex form, inverse operations with properties of equality, right? So someone I haven't heard from yet. Let's see. Z. When I look at this equation right here, I see vertex form. The goal is to use what again, Ethan? Inverses with properties of equality. So Z, what is the first inverse I need to use to solve this equation? Not sure? Okay, I'm going to have someone give us a step to get there. Eliza, in general, how do we know which operation to undo first?
The last one is going to do it.
The last operation being done, right? So Z, when you look up here, what is the last operation being done? What is the last operation applied to x? Minus 13, right? So to undo that, the inverse of minus 13 would be? Plus 13. Remember guys, I started showing you that you can start to number these things to help you out. What is the first operation happening to x? Subtracting by 5. What's happening after the minus 5? Squaring. After the squaring we are? And that's it. That's the last operation being done to that x. X minus 5 squared equals 13. Now what's the last operation? We took care of this one. The square, so I need to square root. Remember both sides, the square root cancels the square. X minus 5 is equal to? Okay. We good? Ready to move on? Alright. What am I doing now?
We add 5 on both sides.
Add 5 on both sides? Okay. So when I do that, I can write that as the square root of 13 plus 5, or it would be the same thing as 5 plus square root of 13. Those are literally the same answers. And you don't need to get the square root, but I got an important question. How many roots am I supposed to have? 2. How many do I have right now? Ooh, we messed up somewhere. Oh, when was I supposed to do a plus or minus? Guys, as soon as you take a square root, make sure you put that plus or minus. Positive and negative. So it should have been a positive and negative square root of 13 plus 5, or 5 plus or minus the square root of 13. Make sure you do that plus or minus when you do the square root. I will point this out. Do you know what type of number this is? Like when we talk about numbers, we have the whole numbers, the integers, rationals, irrationals. We're actually going to talk about imaginary numbers versus the real numbers soon. Anyone know what type of number this is? Not sure? Do this for me. Type the square root of 13 in your calculator. Tell me what you see about that decimal. 3.60555. And is it repeating though? So do this for me. With that calculator in hand, right? Because your calculator is only going to tell you a couple of those values. So square root of, what was it, 13? Notice there's that number, but I'm going to highlight that, hit enter. Look at that decimal again. Is it repeating? Do you really think it's even stopping there, or is that just the last thing the calculator is showing us? It's just the last thing the calculator is showing us. What kind of number does not repeat and does not terminate or end? Hopefully we've talked about this before. Well, a lot of square roots, yes, but they're called the irrational numbers. Do we know about rational versus irrational? Say again? Oh gosh. Okay, so let quick background to make sure we understand this. 2/3, negative 5/4. If you look at 2/3, that's 0.6 repeating. Negative 5/4, negative 1.25. Both of those are rational numbers. This one, because the decimal repeats. This one, because the decimal terminates. Okay? Now, there's an easier way to know that these are rational numbers. Look at the word. What's that right there? Ratio. You see how this is a ratio of integers. If it is a ratio of integers, then it's a rational number. And if it's a rational number, that decimal will repeat or that decimal will terminate. When you factor, you can only factor if they're rational roots. Factoring only works with rational roots. That's why, see how we got a square root of 13 and that number was irrational? I could not factor it because this was an irrational set of roots. That's what's happening there. So, be aware, if they're going to be irrational roots, you cannot factor. Okay? Looks like we need to get up, we need to get to some vertical surfaces, so let's do that. We are dead to the world, at least some of us. So remember, root of the problem, we are trying to first, and this is what the bell ringer was on, we need to have what strategy to solve quadratic equations? First and foremost, we want to factor. And when we factor, we're trying to factor to use what property? Zero product property. We've got to know that. The whole goal of factoring is that a product of 0, I can set each factor equal to 0. But if we cannot factor, the book has us completing the square, but when we complete the square, remember that's not what you're actually doing for me. When you complete the square, what form of the quadratic do you end up with? Vertex form. So we're just going to go straight to vertex form. We're going to write A, H, and K. We're going to figure out what that vertex form is, because if I can get the vertex form, what strategy can I use to solve that quadratic? Inverses with properties of equality. Remember, if I'm using an inverse to change something, I got to change both sides of that equation to balance it out. Today we're going to learn about the quadratic formula. Okay, so we worked through all this. Here's where we are. We did A yesterday, I believe, right? Yes. We did A yesterday. We're going to do B right now, working within our groups at the vertical surfaces. And then we're going to do 1 or 2 more after this that I have already planned. So let's get up, let's move around the room, and let's attempt B so that we can practice using that vertical, or using that vertex form. Okay? So it's on the board, it's also in your book on page 86. No, 84. M1-84. Huh? Your iPad, you said? What?
I already did.
You already did B?
I thought it was the homework at first, but so I did it and I was like, oh.
No, it was not the homework. But that's okay. Work with your group. Notice that we need A, H, and K. So I'm trying to make sure that we can easily see that. A, H, and K. Say again. Page 84. Does that sound right?
Yeah.
Yes? So we want to notice, okay, I need A. A is equal to 1. One thing I do want to encourage you right here is this. Don't just write negative b divided by 2a. Label what that is. What are we calculating when we do negative b divided by 2a? H. And they identify it later here, but write out h equals. It's going to help make sure that you don't make those mistakes. In a similar way, when they substituted this 6 in, what are they calculating?
Okay.
Was it negative 30? Okay. So keep that in mind, that we want to identify that h and that k, and then we need to be careful about our setup afterwards. Right? We got the right answer in one of the groups, but not necessarily what we want to do because it can mess us up. Okay. Let's look at this pink one over here. Bless you. Notice right here, hey listen, this is our standard form right there. When I'm trying to find k, it's not equal to 0. It's equal to k, which is what messed us up right here. We didn't need to do all this. What we should have done was k is equal to negative 30. When I substitute h in, what am I supposed to get out? K. When I substitute h in, I'm supposed to get out my k. So label it that way to help you focus your attention so that we can easily substitute in here. 1 times x minus, was it 6 squared minus 30 is equal to 0, right? Notice, hold on 1 second and I'll answer your question. I just don't want you to think I'm ignoring you. Notice this vertex form, that is the same as the standard form. I've just rewritten standard as vertex, but it still is equal to 0. Now I have vertex form. I can solve it using what operations? Inverses with properties of equality. That's the whole goal. Okay? Eliza, you had a question?
I thought you find k by plugging in h.
Right. That's what I said.
I thought you said find h by plugging in h.
No. I was saying you're finding k here by, and maybe I did say that, and if I did, I apologize. But you find k by substituting h into the expression. Okay? Last thing I do want to point out is this. I'm actually very, very thankful that a lot of us did this because this is going to help us understand when to use each strategy. So over here, most groups erased it, but I want you to see this group. Like many of you started out by doing a times c. Right? 1 times 6, that's 6. And if I do a times c to get that 6, I'm trying to use the AC method of factoring. But do any factors of 6 add up to this negative 12? No. So when we cannot factor, we switch to which method? Vertex. Right? This is a key thing because on tomorrow's understanding check, I'm literally going to give you 3 quadratic equations. I'm not going to tell you which method to use on which. Your responsibility is to recognize when you should use each method. So if you can factor it. If you can't factor it, we should try to use what strategy? Vertex form, right? So please be aware that that is something I'm expecting you to recognize and start to do, is to recognize when you want to use each method. We want to try to factor it first. And there are times when factoring will be easier than using vertex form, and there's times vertex form will be easier than factoring. So I'll be asking you to explain why. Now, we're going to get to activity 5.3 in a second, but y'all have already said, hey, Mr. Kenny, I need a little bit more practice. Some of us do, right? So, here's what I want us to do really quickly. I just want an equivalent vertex form of x squared minus 6x plus 5. This is on the calculators. It is not in the textbook. So let's get up to our vertical surfaces. Let's get an equivalent vertex form of that expression in the calculator. Tevin, what was your point when you started working with your group up here?
I didn't even know it said vertex.
I know, but what did you bring up to your group? Because this is a good discussion point.
I said you can factor.
He said you can factor it. Did anybody notice that? when I look right here, right, A times C gives me 5 factors of 5 that add up to -6 or -1 and -5. So we could have factored it, right? And so will there be times when you can make a decision that you can use either strategy? Yeah, 100%, right? I just did ask you to do a vertex form here, right? But there are times when you can factor it. And so if we had taken that time, it would have come out to be x squared minus x minus 5x plus 5. You don't need to write this down. I'm just showing you something because this will connect to something we look at in a second. This is the factored form. Now, when I look around the room, I think everyone got that h was 3 and k was -4. Is that what you got when you rewrote it? Okay. Do I need to address the idea of how to get h and k anymore? Okay. Yeah, so remember k, and this is one thing I always like to write out as a reminder. H comma k is my vertex, right? Which means h is my input or x value. K then is my output, Mr. King? Yep. Or y value. And so Desiree, you had this question too. Desiree, and I get this, Desiree, you were thinking we substituted into the vertex form, right? But remember, vertex form is what we're trying to get to. So I substitute my h of 3 into the standard form to find what k is. So k is equal to 3 squared minus 6 times 3 plus 5. Which is why we get this, and k is -4. What is? Oh, this right here, this x? Okay, so remember, h is just the letter we use for the x value of the vertex. That's why I said input or x. And so that's a good point. Remember, h comma k, h is the x value of the vertex, k is the y value of the vertex. Does that make sense? Okay, so it's just representing those ideas. Now, around the room, I am seeing a common mistake that we need to be careful of. Right here. This is where the error is. What's the problem with this? Well, they're solving.
You're not supposed to. Well, you're not supposed to. You didn't ask for that. You
Well,
didn't ask
not
for
only did I not ask for that, look at this. Where's the equation? There is no equation.
We made it.
You made it one, but did I ask you to make it one? Nope. Remember, this is just x squared minus 6x plus 5. Be careful and pay attention to that. X minus 3 squared minus 4. That's where we should have stopped. That was it. X minus 3 squared minus 4. We just want a vertex form. Okay? Now, there are two things I want to point out here at this point before we move forward with this. We're going to get one more practice problem. One, these aren't random things. If you have all 3 forms of a quadratic equation, you can actually very easily graph the parabola. When I look up here, I see a vertex of 3, -4. 1, 2, 3, 1, 2, 3, 4. Boom. When I look at my standard form, what feature of the parabola can I easily see from that standard form? The y-intercept, which is what?
0, 5.
0, 5. 1, 2, 3, 4, 5. When I look at this factored form over here, what features can I easily see?
R1 and R2.
The what?
R1 and R2.
R1 and R2. What is my first root? 1. What's my second root? So 1, 0 and 5, 0. Do we have enough points to sketch out a graph now? Yeah. Vertex here. Boom and boom. I think in the future, one of the things that I'm going to try to do is, remember I always asked y'all for the vertex, I asked you for the axis symmetry, all those things. I think I'm going to have students graph it as well to be able to pair what seems like random algebra with the graph, because I think that's going to help us visualize it better. Would that be fair to say? Like if we were trying to make that visual, would that help us learn these things better? Naisha's saying yes. The rest of us saying no. Why not? It may feel like more work, but what I'm thinking is, if I give you this standard form and I ask you to get the vertex, when you get that vertex and you graph it, it's going to help you pair those ideas better and recognize, hey, I'm trying to get the vertex for a graph. Yes? Okay. So some of us saying yes. I'll try it out with the next class. Y'all aren't my guinea pigs for that one. We'll see. I don't know why I started coughing. All right. The last thing I do want to point out is this. If you look over here at this group, right? So this group over here on the TV, they did solve this equation, just like many of us started to. And I want you to notice when they solved this equation, what did they get for their x values? 5 and 1. Wait, that means they got the same as the roots? Well, that should make sense. Because if I set, that's an eraser, not a pen. If I set my vertex form equal to 0, isn't this usually f of x, or my y value?
Yeah.
What kind of point has a y value of 0? X-intercepts. And our roots are connected to the x-intercepts. So that's something we want to be aware of. When I'm solving these quadratic equations, particularly when that equation equals 0, I'm finding x-intercepts. All of these things are related because what is math again? Study of patterns and relationships. Everything is connected and it's a beautiful thing. It is. It's awesome. Woo! All right, let's do one more practice problem before I teach you one final strategy in the last 20 minutes of class. Last problem. So an equivalent, let's actually do this. Instead of just an equivalent vertex form for this one, let's solve, go ahead and solve this equation equal to 0. Okay, so practice solving that equation. So go ahead and set that equation equal to 0. Let's solve it. Cam, come on, man. We need to be actively collaborating. Heads down, you ain't learning. Yeah, vertical surfaces. That's a safe assumption usually. Vertical surfaces. So remember, ladies and gentlemen, active collaboration means that we are collaborating, working with each other to a goal of completing these assignments, but also of growing and learning, okay? And we need to pay attention to a couple of things, right? When I look at this equation, what happens to my negative 1/2? Well, no, they did do it on both sides, but look. Is it right here?
No.
No. Negative 3 times negative 1/2 gives me a positive 3/2. Let's actively collaborate, check each other. It's the right idea. And hear me very clearly on this, guys. Work like this, especially with good explanation, will earn us a decent score, right? We're looking at a 3 with this. Because it is a procedural error, but are they still showing me they know how to get vertex form and use inverses? Yes, they just made a mistake. Okay? We take that square root. X minus 1 is equal to what? Huh? Close. Yeah? Thank you. We gotta remember that positive or negative, right? I will also point this out here when I look at this work. What happened to my square root symbol? Does the square root symbol just go away?
No.
Nope, it's gotta stay there. Or take the square root in the calculator to give you a really nasty number like a 1.7 something 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 because it's irrational. Okay? But that's what I get. And then add 1. Okay? One thing that I do want to point out mathematically, okay, listen, on assessments, one of the things I do want you to notice and I want you to think about and explain is why are you doing the things that you're doing, right? So why did we, I know I asked for an equivalent vertex form, but on an assessment, why would you have used vertex form here instead of factoring?
Because they don't have, their number, like, I forgot what it's called, they don't have that number.
Okay, we gotta learn what that thing's called. What is the factoring method called? What's the name of the method? AC method, right? -2 times 1 is -2. Are there factors of -2 that add up to a +4? So can I factor? No. So on an understanding check, me asking you, hey, why are you doing the thing, right? No factors, add to, you could either say the 4 or to be, so use vertex form. Right? Show me why. I'm not just asking you to do, right? Yeah, doing is useful if we're going to learn more about these things, but more importantly than that, we need to learn how to make arguments. Why are you doing the things that you're doing? How are you going to get to Bryant-Denny Stadium? You're not going to randomly make turns. You're going to have a plan.
Period.
Always. Period. Okay? Now, and I was talking about this with Jamarcus, and I do want to point this out. Jamarcus was talking about, I just don't quite know the equations yet, right? And that's okay. We just can't stay there. Listen, if you know that you don't know your equations, you got to take the time to study. If you don't know the vertex form of a quadratic equation, make flashcards, make a Quizlet, put vertex form of a quadratic equation on one side of the flashcard, write the equation on the other side, say it out loud and see if you get it right. If you don't know h, the x value of the vertex, put x value of the vertex, h, on one side of the flashcard and put the expression on the other side, negative b divided by 2a. Do those things, okay? Now, tomorrow, on your understanding check, there will be one problem where you need to use the quadratic formula. I'll go ahead and tell you this. I will give you the quadratic formula because I am just introducing it today. On assessments in the future, I will not give you the quadratic formula, okay? So do you need to study that quadratic formula?
Yes.
Yes. There are fun songs that you can find online. I ain't the singer, I'm not doing songs. I just learn it, right? If you need a song to help you remember an equation, Google it. There's teachers out there who are way more creative than I am. Use their song to help you remember it. Otherwise, I would just learn this equation. Now here is why you might want the quadratic formula. There's a quadratic equation, yeah? A times C, that'd be 3 times 8, that is 24. What factors of 24 add up to -7? So 1 and 24, -2, -12, -3, -8, -4, -6. Any of those factors add up to -7? No. So can I factor it? No. Okay? Can't factor. Let's try vertex form. H is equal to the opposite of B divided by 2A. That gives me a +7 divided by 2 times 3. That gives me 7 divided by 6. I can do it, but do you want to deal with a fraction like that? Nope. Nope. So I can't factor it. I don't love the x value of the vertex, so I need another strategy. Right? The quadratic formula is pulled out of this need for something else. And so here's what the quadratic formula says. If you have a quadratic equation equal to 0, standard form equal to 0, you can use this equation. This is, on, by the way, on page 85. Thank you. X equals the opposite of b plus or minus the square root of b squared minus 4ac divided by 2a. This only works, I know it sounds crazy. Remember, I'm going to give you the equation for tomorrow, okay? So you just need to be able to apply it. You need to learn this equation eventually, though. This sounds crazy, but the idea is, and I can show you where this comes from in the future, if your standard form is equal to 0, you can always use this equation to solve that quadratic equation. The quadratic formula always works. If that standard form is equal to 0. It always works. That's a nasty equation. I do need you to learn it. once you learn it. It's pretty easy. It is one method that you definitely have to have a calculator for, but I would make that note to myself, hey, I can always use the quadratic formula. Okay. And so, when you look at this equation, and this is the main thing you need to notice, what do you think they mean when they talk about A, B, and C? The A, B, and C from the standard form. So if you can identify what A, B, and C are, just substitute it in. That's it. Notice right here, here's a practice problem on this page. They said A is equal to -4. B is equal to -40. C is equal to -99. And they substituted into that equation, and then they simplified. That's it. That's all you're going to do with the quadratic formula. You're going to identify A, B, and C, substitute it into that equation, and then simplify. And I do want you to try one practice problem like this. So I'm going to get you all up to the vertical surfaces. Okay? And we're going to... I'm going to actually talk about one thing before you get to the vertical surfaces. I do want you to notice here on page, I don't know, 86 or 87. Oh, by the way, you should be on page 85 to write that. Say, see page 85. And 1-85. Yeah, so on page 86, I want you to look here at Meredith, right? Meredith took this quadratic equation equal to 3, said A equals 1, B equals -7, C is equal to -8. But she made an error in using the quadratic formula. Does anybody see her error? And I'll tell you, it is in the very first step that she took. What has to be true to use the quadratic formula? It has to equal 0. Just like with factoring, how the quadratic has to equal, what does the equation have to equal when factoring? 0, so we can use the zero product property. To use the quadratic formula, that equation has to equal 0. What should Meredith have done to start solving this equation? If we do 3 minus 3, does that create a 0? Okay. So that quadratic equation has to equal 0. Notice A is still 1, B is still -7, but now C is equal to -11. That would change her solution. Okay? So keep that in mind. For y'all to work, we're only going to have 3 or 4 minutes. I do want you to know we're looking at this t-shirt problem, and the height of the t-shirt that's being launched out of a cannon is represented by this equation. Notice how there's a decimal in there? First off, if you have decimals in the equation, you're not going to factor it. I'll go ahead and tell you that right now. Usually you're not going to factor it. If I do -b divided by 2a to calculate h, that gives me a -91 divided by -32. Do you want to deal with that h value for the vertex? So what are we going to use if we can't factor and we don't want vertex form? We'll use that quadratic formula. Get up, move to your vertical surfaces. I want you to solve, what does it want to know? How long will it take for the t-shirt to land back to the ground? So if the t-shirt lands back at the ground, what is the height? Think about it, guys. If a t-shirt is landing back on the ground, what's the height? 0. So this equation is going to equal 0. Get up, let's solve that equation. At least substitute your values into that quadratic formula. Just a few minutes to substitute our values into that quadratic formula. Yep. Eyes up here, I just want you to notice. The first thing that I would do, hey guys, I'm trying to use this equation. X is equal to these values, or this expression. So what do I need? I need A, I need B, and I need C. Identify them. Write it out. A equals -16, B equals 91, C equals 5.5. That's going to help make sure that you don't make any mistakes. Now we need to be careful and pay attention. This does say the opposite of B, doesn't it? So this 91 needs to be negative, right? And hear me clearly on this. If you can substitute into the equation and tell me why you're using the quadratic formula, I am going to be okay for now. It's going to earn you the majority of your credit. Be aware tomorrow you're actually going to be in the library with Ms. Bauer and Mr. Kilpatrick. Make sure you know how to substitute in, no homework, so that you can focus on preparing for your understanding check.
You gonna be at home?
I'll be at UA.
Are you leaving?
Huh? You come join us? Oh, you're doing your own thing? I got you.
Are you leaving your conference?
Yeah.
You wanna keep that?